Welcome, everyone. For today's prep, we're going to be looking at profit, revenue, and cost functions. And in particular, we're going to first start to look at what happens when we differentiate these types of functions. So that's going to be our marginal profit, revenue, and cost. And then where this is leading is we'll see how we can apply our optimization techniques to optimize profit or optimize revenue or optimize cost. All right, so what is the scenario here? We're going to pretend, get our imagination going, we're going to pretend that we're a company or maybe an entire industry that produces and sells one particular item. So we're going to kind of have a narrow focus on one particular item here, and we're going to use variable X to denote the number of items that are being produced or sold. Okay, so X represents the number of items. X is a quantity here. And in general, when we talk about X, when we talk about number of items, X is usually a non-negative integer. So 0, 1, 2, 3, things like this. So we have these kind of discrete quantities of number of items that we're producing. 0 items, 1 item, 2 items, so on. But we're going to assume that X can take on decimal values. That way we can do some calculus. Okay, so again, X here represents quantity. So whenever we see an X, and we're talking about profit or revenue or cost, X is usually going to represent the quantity. All right, so our functions that we're going to be working with, there's our cost function, which we call C of X, and this is the cost of producing X number of units of our product. There's the revenue function, which we'll call R of X, and this is the revenue generated by selling X number of units of our product. And then there's the profit function, which we call P of X, and this is the profit, or it could be negative profit, so a loss, generated by producing and selling X number of units. And the way we figure out our profit function is this is revenue minus the cost. So you want to think of cost. This is the kind of the money that we have to pay out in order to produce our number of items. So things like machinery, labor, all the buildings, all those things that go into producing our items. So this is the money that we have to pay out. Revenue is all the money that we bring in, all the money that we get in. So revenue is not how much money we get to keep, because some of the money that we bring in, we then have to pay out to kind of pay off the costs. So profit is what kind of looks at the leftover money. So profit is the money we keep. So revenue, not the full story there and how much money you're actually getting to keep. That's what profit is. Whoops. Okay. So, what happens if we differentiate these functions? Well, we get something called the marginal functions. So, the derivative C prime, the derivative of our cost function, this is what we call marginal cost. And, well, R prime is, you can probably guess, it's marginal revenue. And then P prime, well, also, it's a marginal function, and this is what we call marginal profit. So what these marginal functions do is they kind of give us a way to measure how much profit, revenue, or cost would change by selling one additional item. So this is going to be our interpretation of these marginal functions. They give us a way to measure how much either our profit or revenue or cost, whatever we're investigating, would change if we were to sell or produce one additional item. So they're measuring the change in our cost, or the change in our revenue, or the change in our profit. It's kind of what we've seen with derivatives before. Now, one other thing before we go on. Sometimes, so we have a formula for profit. Profit is revenue minus cost. Sometimes we also have a formula for revenue. So a lot of times in these examples, revenue is going to be, let's write it out, is going to be the number of items that we produce times the price that we sell them at. And this is little p, not capital P. Capital P is for profit. This is little p for price. So we've got our quantity, X, and little p here represents price. So this is lowercase p. So, if we were to sell five items at $10 a piece, well, our revenue would be $50. Makes sense. So if we were to sell 10 items at $20 a piece, well, our revenue would be $200. So revenue is a lot of times the quantity, the number of items that we sell, times the price that we sell them at. And a lot of times this price is kind of related to the number of items that we're selling, which we'll talk about in class. All right. So let's try one example. So let's suppose that the cost of producing X number of items is given by this cost function C of X. And the units here are dollars. So our cost function is 0.005 times X cubed minus 0.5 times X squared plus 28X plus 300. Okay. And the first part of this is asking what is the marginal cost when X is equal to 50. So we see that keyword marginal. We want to think marginal means derivative in the case of profit, revenue, and cost here. So we want to calculate our first derivative. So let's calculate C prime of X. Differentiate the first term. We get 0.015 X squared. Differentiate the second term. We get negative X. And then plus 28. All right, so that's our marginal cost. And it's asking, what is this marginal cost when X is equal to 50? So we're going to plug 50 in. And when we do that, we get 0.015 times 50 squared minus 50 plus 28. And if we calculate that out, we get 15.5. Yeesh, what's going on today? 15.5. Okay, so, well, what are the units here? Well, the units for a derivative are going to be the units of the original function divided by the units of the variable. So the units of our original function are dollars, and the units of our variable are number of items. So the units here are going to be dollars per item. So it's units of our cost function divided by units of our variable x. All right, so what does this value mean? So let's interpret this result. So what this is saying, because we plugged in x equals 50, that means we're at a production level of 50 items. So we're currently producing 50 items. And what this marginal cost is telling us, well, first of all, it's a positive value. So we know we've seen it before. We're interested in knowing when our derivative is positive or negative. So in this case, the derivative is positive, so that means cost is increasing. And it's increasing at a rate of $15.5 per additional item. My fives today. Of $15.5 per additional item. And again, we know it's increasing because this derivative value is positive. One other kind of interpretation of this, another way to kind of phrase this, is that, again, the derivative kind of gives us a way to kind of predict what would happen if we were to increase, in this case, increase production by one additional item. So the marginal cost in this case would tell us, so a different interpretation or a different way to phrase it is that the cost of producing the just the 51st item. So assuming we've already produced items 1 through 50, so all those are manufactured, and we want to make one more. We want to make a 51st one. The cost of producing just that one additional item is going to be $15.5. Roughly. This is giving us an estimation. Good estimation, but an estimation. So you can think of this 15.5. One, it's telling us at this current production level, is the cost increasing or decreasing? So in this case, it was increasing. It's telling us the rate at which it's increasing, so $15.5 per additional item. But we can also take this, kind of interpret this slightly different. And this 15.5 is telling us how much it would be if we've already produced and manufactured items 1 through 50. This 15.5 is going to tell us how much that very next item is going to cost. And that's what marginal means. It's how much that next item is going to cost, or if we're talking about profit, how much we're going to profit from it. All right. So we're going to look at a few more of these in class. So we'll see you then. Bye-bye. Jeez, sorry. Oh, getting all choked up on marginal analysis here.